All right, so today we're continuing by practicing some of our exponent rules that we were taking a look at a little bit last week. We looked at them really quick. And last week we saw, okay, the general rule is that when I multiply variables, that means I add their exponents. And so we can go ahead and do that with this problem here. Now the 5, you'll notice that's just a 5. It's just a number, so it's going to stay a 5. And then I do x to the power of, and I add the two exponents. So I add the 4 and the negative 9. And if I add those, I end up getting negative 5. But the new little variation is that we can't stop here. Because in order for something to be considered truly simplified, it should have no negative exponents left in the expression. And this has the negative exponent there, so I got to get rid of that. Now a negative exponent means flip it in the fraction. Now you might be wondering what fraction is there. There's not a fraction here. There is though, it's just that the whole thing is considered to be over 1. And so the part that has the negative exponent attached to it, that's going to move to the bottom of the fraction. Now, think this through. What actually has the negative exponent attached to it?
X.
The x. Notice the 5 here does not have the exponent attached to it. That 5 is just a 5, so it stays on the top. The x that's to the negative 5, that flips into the bottom. When we flip it, we also then turn it into a positive. So it's 5 over x to the 5th. And then this is now considered simplified. This is our final answer. All right, now taking a look at this one, the same basic idea is going to be true here. The first thing I always like to do is I like to simplify within the top fraction or the bottom of the fraction as necessary. And in this case, that means I'm going to go ahead and just combine these two x's at the start. And I'm not going to worry about the flipping with the negative yet. Some people do that at the start, but I tend not to. Either way would work though technically. So I'm just going to combine those on the bottom, which means the 8 and the 3, they're untouched, but I do combine the x's. So I have x to the negative 6 and x to the 2. I add those two exponents, so that gives me x to the negative 4. Now the negative 4, of course, that negative exponent means to flip that within the fraction. But again, what's the negative exponent actually attached to here? The x. Notice it's not attached to the 3. One of the things that happens as we start doing these is that you'll find yourself really wanting to move that 3 as well. But the 3 does not have the negative exponent on it, so it does not move. So the 8 is still on top, but now the x to the 4th is also on top. When I flip it in the fraction, it becomes positive. And then that's all over the 3. And so the negative exponent, remember, flips it in the fraction. Either flips it from the top to the bottom, like in our first problem, or flips it from the bottom to the top, like it did in this problem. All right, so for this one, again, we approach it the same way. And in fact, in many ways, this one looks a lot simpler. And in some ways, it is. I have 3 x's, so I go ahead and add all of their exponents together. So I do 3 plus negative 7, which is negative 4, plus 4 is 0. So the whole thing ends up being x to the power of 0. It's just that this problem is here specifically to answer the question about what do we do when we have something to the power of 0? What does that equal? Well, the answer is that anything to the power of 0 equals 1. And so, the basic idea here is that, like, when we see x to the 0 up there, that's like saying it's 1x to the 0. There's that invisible 1 hanging out front. And so then if you take away all of those x's, notice you're left with the 1 behind. And so that's why anything to the power of 0 is just going to equal 1. And so, a couple little rules there today. Negative exponents, flip it in the fraction, and anything to the power of 0 equals 1. And once you have that down, then you're good to go.